we discuss finite impulse response filter. Today we are going to discuss infinite impulse response filter. The fundamental difference between the two is evident from the name, is that the IIR filter are going to have infinite impulse response, not having finite number of samples in H of n. It is going to have infinite number of them. How they are generally represented, this is their general representation in the form of expression y of n equal to b naught x of n, p1 x of n minus 1. This first portion is actually your FIR portion. If you remove the second portion, which is the feedback portion, then it will become an FIR filter. So the feedback is the portion which make this filter having an infinite impulse response. The IIR filters are actually filters with memory. They are feedback filter, so they need to have previous values. They are not only dependent on the current values of the input, but they are also dependent on the previous value of the output as well. This is why they are usually termed as the feedback systems. Their corresponding h of z, which is the transfer function, is represented like this. With these are the parameters for the input, and these are the parameters for the feedback. So if you can see, it's represented by a1, that raised to power minus 1, and so on up to an. The order of the filter, IIR filter, unlike the FIR filter, it is not related to the x of n minus m. It is related to the feedback portion. So in this case, n actually represent the order of the filter, because n is the part of the feedback portion. So if it's y of n minus 1 only and not other terms, the order of the filter is going to be simply 1. Doesn't matter how many components of x are out there. Also, if you look at this, the numerator represents the zeros and the denominator represent the poles. We had discussion about it previously as well. There are different methods of how we can design an IR filter. One method is that you guys have previously studied analog filters, Chebyshev filter, Butterworth filter, those kind of filters you have studied in analog. So one of the beauty of the IR filter is that you can simply transform any of the analog filter into equivalent digital filter by substituting some values. So what are different methods to do so? We are going to discuss that in a while. But you have to make sure that when they are when it's shifted from the analog to digital, the system is still stable. If you remember, in case when you take the Laplace transform of a system, and when all the poles are in the left half plane only, then the system is stable. Otherwise, the system is not regarded as stable. In case of digital filters, you have to make sure that all the poles are inside the unit circle. If they are not inside the unit circle, we can't regard them as a stable system. So stability is the important parameter. So when you are transforming from analog S plane to Z plane, you have to make sure that the system stays stable. So generally, if you remember, the derivative in time domain was represented by S, and the time shift in case of the discrete system is represented by Z. So how these two are related, how the differentiation in time domain is equivalent to differentiation in n domain. So let's move on and let's see what are the impact